Today I'm looking at fixing this Salter dual basket air fryer, which retails for about £70. The model number is just here. It is an EK4750BLK, and like a lot of air fryers, it has a a known issue that the overheat fuse blows inside them, which means that they stop working on one side. This is basically a one-time fuse which is connected to a piece of wire which is connected to the element. In fact, they have two of them, one on the negative, on the neutral, one on the live, and if one of those blows, then one side just stops working, the element won't get hot anymore. They're very deep inside, quite hard to reach. The part is something you could order individually, or you could salvage another air fryer and then take that part out of it. So actually what I've done, I had two of these, there's another one over here, which I was asked to fix, and I've taken out of the other one the whole heating unit, and in the back of it here, if you look at the back of it, you can see these two things here with the white heat shielding on them. There's one, two of them, and they go up to these wires, red and the blue ones, and they are the two thermistors which do the isolation. You can't reach them without totally disassembling the machine, which I'll show you in a minute. There's no point in taking it apart from this side because you just won't reach it. And in fact, there's another evil gotcha here, which is that this fan that you see here is a reverse thread bolt, so you have to remember it actually turns the opposite way, and that might be why you've never managed to undo that one so far. And you also need to hold this still while you undo it, which you can't do using this, so you generally will strip it. You have to hold inside to do it. But even if you did undo all of that, you still couldn't take this out, because you can't do so without taking all these cable clamps off the parts inside it. And in fact, cutting the earth one, you have to recrimp that. The others all can be detached, but you can't do that without totally disassembling it. So the next thing we're going to do is take it completely apart. First, always remove the drawers. Like so. Now let's just have a look around it and see what we've got to do. On the bottom of it, and here, there are 1, 2, 3, 4 screws there, another one there, 5, another one there, 6. So 6 screws you have to take off at the bottom. On the very back, there are 2 more screws here and here, which have to be undone. And that you think, oh good, look, that's all the screws, but it isn't. The others you have to get to by taking this whole front off, which is just clipped on. You have to prise it off. So I shall just pause the video and undo those screws first. Okay, so I've undone those screws using the driver, 1, 2, 3, 4, 5, and I'll now undo these ones at the back. Actually, one of them's already missing, but I'll undo that one there. Might as well leave the camera on, it only takes a second. There we go. Put the rest of my screws. So there and there, all gone. Oh, yes, and there's some more little screws along here. I failed to point out there's 3 of those. Now we need to prise the front off. Okay, so I've prised all the bottom off to there, as you can see. Now, actually, I've just remembered that to get the top bit off, you have to take the screen off first, because there's some more screws behind the screen. So I shall just do that. Just prise this screen off. There we go. This one's a particularly tricky little bugger to get started on. Once you've got something sharp under it, you can start to prise it off. There you go. Prise is easier from the front to start with. I have to get a sharp knife under it in the end. And put that much of it off now. As you can see, the screw starting to appear in there. Look, there's a screw secretly hiding. So let's pop the rest of this off. There we go, so that's loose now. As you can see, it's got a cable connected there, which you can slip off backwards towards the back of the box, so you can get this completely out of the way. You have to pull that clip on the side away from the unit to get it off. Okay, so that's off. I'll put that over there. And now with that off, you can see 1, 2, 3, 4, 5, 6 screws to remove there. Is that one there? No, 1, 2, 3, 4, 5, 6. Let's remove those 6 screws. Okay, so we've got all those screws out now. So now we can finish prising off around the rest of it. See, but what actually stops it coming off next is actually, believe it or not, just the cable. The cable has a strain relief thing there, and that stops the whole unit coming off its back because the back's being attached by this. So you have to remove this strain relief. You can kind of prise it out towards you, and then it unfolds off it. So pull it this way and then unfold it. You see it being prised off by the screwdriver. So just going to pull it all down. There you go, see it's come out, and then it kind of splits like that, comes off like so. Now that gives you the cable. The cable's actually got another strain relief inside, so don't pull on the cable. But now, once you've done that, the whole top should come off. So now you can press on those bits there, and the whole case comes off like so. You can feed the cable through it to get that bit as far away as you like, leaving you with the real thing, the rest of it. You can see there's the motors for the fans. They've got a fan above and below, one fan that cools the interior of the unit, which is there, and another fan below that actually cools the blows the food. You've got your control board and you've got your wires, and here you can see the top of one of these coming through. And you can see what I mean by the fact you couldn't drop it down because there's not enough wires space. So what you're going to need to do is drop that whole unit down. You could probably just about do it in place by undoing all these screws and then feeding it down into this cavity down here, maybe, if you're replacing the whole unit. But actually I found it easier to take out the whole top off, which actually probably means I'm going to have to take this front off anyway to get to those back screws. There's screws all the way around there, and then there's also 2 screws there, you can see, just there, and then there's another 2 screws down there, just there and there. But there's also, I think there's some at the front as well. Yes, there's another 2 down there. So I'm going to remove the front now, just so I can get to those. Okay, that wasn't particularly difficult, taking off those last few clicky bits, but anyway, so it's off now, and now you can see the last few screws that separate this top heating housing from the bottom bit that holds the drawers. So my ultimate goal here, by the way, is to replace the one of these that's not working with this unit from the other one that does work. They're both identical. You can see in hand they're in different colours as well. So one side has red wiring and one side has white wiring. White wiring. Can't promise they'll be the same as that afterwards. Maybe they won't. They'll be a different colour probably. It doesn't matter. So you can see the red wires will have to come off here, and blue wire off here, and then also there's a wire that goes round to the element itself, and so the red and blue would have to come off there if we're doing this side. And then the last one is the earth, which is here, which goes down there, and the earth here. Now this earth here is already crimped to the main inlet, so you'll have to cut and recrimp that, and that's okay. Right, we are. Other side again, likewise, you've got the 2 element wires which go onto the board. No, sorry, the 2 element wires which go straight down there, and they come back out of there and go here. So to choose which side we're going to do, I just need to test it to see which side is broken. Okay, so telling which one's broken is pretty easy. All you have to do is remember that the wire goes from the element, there we go, down into the case to the magical fuse, back out of the case to the red one here, and then likewise the blue one comes out of here, goes down into the case to the overheat fuse, back out there to here. Likewise over here you've got the blue one which goes over here, down into the case, the overheat fuse, back out of the overheat fuse to here, and the white one which goes over here, down into there to the overheat fuse and back out to here. So if the fuse is gone, you won't get a beep between the circuit board and the element. So all we have to do is put one of these, let's test the red fuse, so we put one of those there, and then the other one over here. It's going to be tricky for me to do that with the camera, but I'll do my best. Let's see how we do that. I'm going to get it so you can see it. I could do it with 2 people really, but I put this between my legs. Can't be a bit professional filming, can you? Right, so this definitely isn't it. So we're going to put one of those there and the other one over here and see if it beeps. it does beep, so the red fuse has not gone down inside there. And the red fuse, let's try the blue one. So we'll put one there, over here. No beep. Aha, we say. Okay, so the blue fuse has gone. Now we'll go over here and try this one's blue fuse. So we'll go between here and the blue one on the circuit board. And we get beep, so that blue fuse has not gone. Then we'll go between the white one and the white connection on the circuit board, and it beeps. So the white fuse has not gone. So the only fuse that's gone is the one on the blue wire here. So the functionality of this unit would be that this side doesn't work and this side does work. You also, if you've got one, you can check if it will blow your house RCD. If it's got an earth leak on an element, for example, all you would do to that is put one of your mega testers there and the other mega tester on something earthed, and check that it doesn't read less than 1 mega ohm. And you do the same for the other element. Actually, I'll probably just go and get mine to do that now, because otherwise I'll fix all of it and it'll still have the same problem. This one I've already tested, this spare one. So seeing as I'm going to replace the whole unit over here, I guess we've sorted that one. But if this one had a leak of earth, then I'll have wasted my time. Right, now I don't expect you to do this test unless you happen to be a Sparky, because you won't have the unit because they're bloody expensive. But what I'm doing here is I've got my mega tester set to 100 volts, which will be enough. I've put one side of my tester onto the element and the other side onto a good earth. I'll now press test. And we can see this one passes greater than 200 ohms. That would not blow your RCD on your house. Now we'll move across the other one. Okay, once again between the element and a good earth, between the element connection, not the element itself, but the connection, of course, we're talking about to the terminal. Let's press the test button. Good. So there's nothing connection-wise wrong with those. No, there's no earth leak on those elements. Going back to the other tester, we could also test that the element is good if you want while you're here, just as a another exercise. So you could get your standard voltmeter, standard multimeter, and set it to perhaps 2000 ohms in there. That's the 2000 in the horseshoe. Okay, and it shows a 1. That means no connection at all. And the 1's over that side. That means infinite. There's no connection. Surprise, surprise! If you touch the two together, then you get nearly 0, or 0, meaning that there's a very good connection. So you want to check to see if there is a connection between each side of your element, because otherwise clearly it's not going to work because it's melted or something. So I'm going to do one-handed. So again, here's the element. I'll put one there and one there like that. And we'll look down there, and I'm looking for about 45 to 50, and that's what we've got. So that element is good. That element is not blown and it is not leaking to earth, so it's a good element. And go to the other side. Put that there, like so, and down there again, 48. So that element has not gone and is not leaking to earth and works. So it's a good element. So actually, the only thing that's gone wrong with this unit is that thermal fuse there. Now we'll have a look when I take the broken one out as to what those are, because you can buy those separately, and then you'd have to attach it onto the wire. You're probably best to weld it onto the wire, because I suspect if you solder it, there's a chance it could melt under the heat. I need to check that, whether it could cope with the temperature. I suspect not, because they've welded them on. And you can get a spot welder on eBay very, very cheaply, like a tenner or something, that just does quick spots onto connections like that. So it's probably best to do that like they've done when they made this. I doubt you'll find one with the cables as well. I mean, if you do, then even better. It might be you can buy a thermal fuse from a air fryer that does supply parts. This one, they don't provide parts, but you probably can buy one from one that does supply parts that might have cables, and then you could just use that, as long as it's got the same rating that it blows at, and we'll look at that in a minute. But now I've got to unscrew all these screws around here, like that, and remember those two there, and then the other two that are hidden in here, which I'll go down here to undo. And also I have to undo this piece here, which has 4 screws, and under there I'll let you reach those two in the middle. And then this whole thing will come off, and I'll show you that. It is a shame you can't get the thermal fuse out here without disassembling it, because you can kind of reach through this hole just about that screw to undo it. but I don't think you'd ever get it back, and I don't think you'd be able to get the thing through the hole. So you're kind of stuffed with that. You're forced to, because it's not really intended for servicing, you're forced to take the whole thing apart to get to it. So I'll do that now. Okay, I'm halfway through unscrewing it all. I'm nearly through. I'll just try to show you taking this bit off. Put that there with the rest of the screws for it. And then you can see you can reach those ones in the middle more easily. And those ones you can kind of do on the piss with a screwdriver and slant. Worth mentioning, it's well worth having a electric screwdriver. That just takes a few moments to undo all those. It'll be much slower doing it by hand. And there was 2 little screws in the top there to take out as the last bit, and then it'll all unfold. And there we have it. I removed those little 2 screws from just in between that one there and there and there. The whole thing now lifts off, like so. So now you can have your 2 compartments with the wires cable tied to it and the top of the unit, and now you can see all the stuff. So next we need to undo, if we're going to replace the whole thing, which we are, technically we only need to do that bit, we might as well replace the whole thing since we're here. We have to undo those 1, 2, 3, 4, 5, 6 screws there, and loosen those 2 screws there a bit, and then this will all come loose. Won't come out yet because we haven't done the terminals at the other side, and we have to undo that bolt, which was reverse threaded, remember. So there you go, those screws are out all the way around the outside. Don't need to take that one out, and it won't come out though because that is bolted to this. So what you need to do is hold that still while you undo it. Actually, these adjustable pliers might hold it still, it turns out. Hold it still, probably for long enough to undo it. Remember, tighter direction clockwise to undo it. There we go, and I was actually able to do it just with a normal spanner, just to see if I could. For you guys, I could undo it with the normal spanner. It's loose now, doing that technique, so that's probably the best way. Okay, and that is the order they go onto that spindle. There's this bigger nut, washer, then this slightly smaller washer, and then the reverse threaded nut. So that is now undone. So now the only thing holding it in place now is the wiring. So we're going to unplug this one, and this one, and this one, and undo this screw here, which is really tight. I was just using a flathead because it seems to eat posi drives, so a flathead one there, and to get that off. And then you'll have to cut this wire down here somewhere, the other earth, somewhere where you can recrimp it. I'd suggest down here somewhere out of the way of the heat. Okay, so thing to point out with these is these have got little clips inside them that you have to press in order to undo them. So you have to take off some of this black lining and then press in the clip. I'll show you one in a sec. Okay, see how I'm using my multimeter pointed part to press it in on the back of the terminal there. If you don't do that, especially on these, you will just rip the terminal off the circuit board, and then you're screwed. You'll need a whole new circuit board, or you'll need to solder a new one onto there, which will just be a ball ache. So you must make sure you press in the bits on the side of them as you pull them out. There you go, you can see a tiny little hole. That's where you have to press. The other thing you can do if you're approaching the back of them is to, there's the bump you see that sticks in, is to prise a knife in behind the other side of it, in there, and leave that away so it comes out. You've got to move that little bit in the middle basically, haven't you? Okay, so I've got those 2 off. There. Which we can now thread back over here. Now we've got these 2 off the circuit board here. I'm just going to do this one now. As I say, flat-headed. Now you have to press down really hard as you turn it, otherwise you will just strip it. It's so tight. Okay, and finally we have no choice but to cut this wire here. Leave yourself enough room on it to crimp a new connection on. Okay, that's everything through that hole now is loose. We don't need to remove the fan connections because the fan is staying where it is. We just now can thread that all through there, like so, and remove the element from the other side of it. Just like yanking it, remember you do have to slightly loosen those 2 as I said earlier, otherwise it doesn't come out. Those are screwed through this and through the plastic. Now it's just a case of getting it out and the wires out. And there we go. As you can see, dead one. Oh look, I've forgotten a bit. Look, there's that other sensor at the front, which is the temperature sensor. Let's unplug that one. Of course, silly me. That one here is these two thin wires here, which go back over to here. Yes, you do have to cut off some cable ties when you do that one, so you'll need to put some new cable ties on afterwards because it won't fit through them. So let's take a little sensor out before we destroy it. Again, I've got another one, so I don't mind too much, but you might not have if you're just replacing the overheat fuse. Yeah, so this now has to be back through there and out as well. There we go. We'll pretend I remembered that the first time. There we go. This is the offending dead one. Identical, they've got different colour wires on. Both those heat sensors are the same. So if you can get hold of either one of those, it doesn't matter. You could use that as the other one. And likewise, between the two sides, they're exactly the same. And we'll get the break one out now and you can see what it is. Okay, if we pull its little sheath back, here it is. Let's see if we can zoom in enough for you to see what it is. I'll read what it says on it for you. It says RYE, which is the brand make, and then the model number is DKDZ. Okay, DKDZ, and then TF 185 degrees C. So it's a thermal fuse TF 185 degrees C. So that's the temperature which it will melt and never work ever again. Yes, so any thermal fuse that's rated at 250 volts, 185 degrees C, would be okay, provided it can cope with the current. And this is marked at 10 amps. So it's overrated actually, which is good, because it only powers one side of it. So, yeah, so 10 amp, 250 volts, 185 degrees C. Or if you want to get the exact one, it's a DKDZ TF185, made by RYE. And you can see they've... Actually, I haven't spot welded it. I tell a lie, that's crimped. Okay, so if you had some crimps of that size, you could crimp on a replacement one, because it won't come with these wires most likely, unless you buy one, as I say, for another similar fryer, and then you might get wires with it. They need to be heat-proof wires. Obviously, you can't just use rubber ones. They have to be these braided ones. Otherwise, they're going to melt, aren't they? And then bad things are going to happen. So don't do that. But yeah, so that's the dead one. As I'm going to replace the whole thing, I think I'll just put all of this over here. But I do have, of course, now I've got a spare one, because this one is okay, as we know. So I've got one spare one which I can keep, and I've got a good element actually as well in there. It's only the thermal fuse that had gone, but I might as well put this whole unit in because I know this one to be good. So reassembly is really just the reverse of assembly. What I'm going to do is put all those wires back through there and put it back in those screws, redo up the reverse thread screw here. But we'll go, okay, we'll I suppose you can watch if you want. Right, I'll just put the wires back through. Okay, I threaded the wires through, pushed it back on, done up those screws around the outside. Remember to do up these two you loosened, because you didn't take them all the way out, so you might forget. I would suggest doing them back up again, would be a good idea. There we go. Right, the fan's back on its spindle, so I need to do back up that reverse thread bolt. Okay, that's done back up. It spins nicely, which is good. I held it again with the pliers on the other side as I did it up. Okay, so I think that's everything from this side done. So now we have to go and put the crimps back on, the connectors back on. Right, back on the top, there's the short and easy ones, and then the slightly longer ones. So there we go, let's put the red one back onto heat 1. They're nicely labelled on circuit board actually. It's almost like they wanted to help you. Okay, so that one's on. It's a little bit loose, so what I'm going to do is push back the bit I bent out so it bites tight. There we go. So what I actually did to make sure they were nice and tight, and it's very tight now, was I put a pair of needle nose pliers like that and squeezed on it a bit to make it tighter. Okay, those are plugged back in again and pushed into those positional lugs there. We just need to put this back in here and then recrimp this with a new crimp. Okay, that's that back connected. We need to cable tie those, so I shall go and get some cable ties from my store. and also a crimp for here, and then electrically we're finished. You can kind of see why they don't bother doing repairs for it. If it's only £70, this probably would still take you an hour to do it. Maybe if you're really fast and you need more time, you could do it in half an hour, but it's probably £30 labour, £30 to £40 labour, even cheap, maybe £50 labour if a store did it with premises, but which time you paid for the part, there's not much point, is there, really, sadly. You'd rather just buy a new one. So the only really viable people to fix it are owners. There we go, so I've re-crimped that, sorry, re-cable tied that. Now I'm going to bare this and put a crimp on it. That's a butt connector one I shall use. I don't know if it's red or blue yet, I'll see how much wire there is. It's probably a blue. One of these, and crimps, and crimp it together. In fact, it's a red one. There we go, that's crimped that together. Yeah. So electrically, we're all done. We just need to now put all those screws back in the top of it to unify it with the base. Put on that U-shaped piece on top of that, and then put it back inside its outer case. I'm probably going to test it first, so I'll seat it nicely on top of the lower thing, but not actually attach it in, and then put the face on loosely on the front wire and just check it works. Obviously you have to put both drawers back in, otherwise it won't activate those sensors. You could bridge them, but hey, why bother? I've connected the screen back up. It's all sat nicely as if it was fitted. Just double checking, all that's left is casing screws, so we're all good to test it. Let's see if it works. Right, before I power it on, I'm just doing an earth leak test from the plug socket onwards, because I don't particularly want to blow the earth trip at the house. That'd be annoying. So it's still okay. It's not going to blow the earth trip then at this moment. Of course it could do once the element engages later, but we've already tested those, so it won't. No, that's all good. Okay. Okay, so I've turned it on, plugged it in, switched it on, switched both of them on. All I'm going to do is wait a little bit. It's all working. I'm merely going to let it run just a little bit, then turn it all off and unplug it and just check the fuel's hot in there, and then I'll know it's all working. The chances are it must be. But yeah, looks good. Just needs all screwing back together now. Hooray! Okay, that's enough. Turn it off. Before I set fire to my carpet. There we go. Okay, let me press stop. Turn it off. Splendid. Job done, I think. I don't think I'll bother showing you the screwing those case screws back in. It's kind of all just noddy, really, isn't it? Just put all those screws in. The only difficult bit really was, well, none of it's difficult. It just takes a lot of time. Right, it's all working still. I would suggest that what causes these fuses to blow is people putting things on top and blocking these vents, because those vents don't vent the inside of the cooking area. They actually vent the bit where the heat sensor is, the overheat sensor is. There's a fan there that tries to keep the electronics, because it's not insulated, it keeps the electronics cool by fanning all that air from that void out here. And of course, if that's blocked, that void will raise to the same temperature as the cooker, which will then melt the fuse.